Problem 61. In the given figure, the ideal batteries have EMF E1 equal to 12 volt and E2 takes the value of 4 volt. So the first question, we are going to find what is the current in the circuit. And the second question is, what is the dissipation rate in resistor 1? So that means you have the resistors R1 and R2 and both are the external resistors. So you have to find what should be the power. The dissipation rate is nothing but the power. So what should be the power generated in R1? And in the third question, we are going to find what should be the power in R2. And then the fourth question, we are going to find what should be the energy transfer rate in the battery 1. And in the fifth question, we are going to find what should be the energy transfer rate in battery 2. And then the sixth and seventh is the theoretical question. So first of all, let's finish our numerical part, and then we can just solve the last two questions later on, okay? Because it's purely based on the theoretical part. So let's start with the given first. So what are the informations given in the question? The EMF value of the first battery is E1 takes the value of 12 volt, and the second battery EMF E2, which is 4 volt, and then R1, which is equal to 4 ohm, and R2, which is equal to 8 ohm. So in the first part of the question, we are going to find the current. So what should be the current in the circuit? What should be the current in the circuit? That means we are going to find the value of I. So if you want to find the answer for the current, first of all, you have to apply the loop rule or Kirchhoff's voltage rule in this circuit. So what we studied? The algebraic sum of the EMF, which is equal to the algebraic sum of the product of resistance and its respective current. So in one side, you have to separate the EMF batteries. That means the battery EMF, you have to separate one side of the equation. In the other side of the equations, you have to take the product of the current and its resistance. So the most important thing, if you have two batteries, as I already mentioned, you have to see which battery is stronger. So if you see here, our battery first is the stronger because which takes the value of 12 volt, but our second battery EMF is 4 volt. That means the E1 value is stronger here. So I have to consider the direction of the current like this. So that means the current will be going like this. Clear? So the current initially it will be enter R2, then it will be enter R1, then this current is against the current of the second battery. So I have to consider the direction of the current like this. Now I'm going to separate the battery one side, and then in the other side of the equation I'm going to take the product of the resistance and its respective current. So let's see this EMF here. So EMF 1 is stronger, so I have to take E1 takes the positive, and E2, you can see the E2 is against E1, so we have to take the negative of E2. Why it is negative? You can see this red arrow. So E1 arrow is in this direction and this arrow is against this direction, so and it is opposite, am I right? So opposite current of both. So that's the reasons we took negative here. And in the right hand side, we have to take the product of the resistance and its current. So I multiply by R2, and this I again enters R1, so plus I multiply by R1, that's it, because we have two external resistance. So now by using this, we are going to find the value of the current. So here current is the common term in the right hand side of the equation. Let's take current as a common. So inside the battery we have R2 plus R1, and in the left hand side we have EMF1 minus EMF2. As we are going to find the value of this I, so I can just move this R2 plus R1 to the left hand side of the equation. By that the equation will modify as current I, which is equal to EMF1 minus EMF2 divided by R2 plus R1. And we have all the values for EMF1, EMF2, R1, R2, all the values which is already given in the question. So what I'm going to do, I'm going to substitute this value here. So what is the value of EMF1? The EMF1 is 12 volts minus what is the value of EMF2, which is 4 volts, divided by R2 takes the value of 8 plus, and R1 takes the value of 4. So now I have to find the value of the current. So current I, which is equal to, let's see what is the answer. So 12 minus 4 divided by 8 plus 4. I got the answer here as 0.6666 I got. So better I can round it the value 0.6666. 2.667 and the unit for the current is ampere. So this is the answer for the first question. And in the second question, we are going to find what should be the dissipation rate across resistors R1. We have to find. So that means in 4 ohm resistors, so here 4 ohm is nothing but your R1. So your R1 takes the value of 4 ohm and your R2 takes the value of 8 ohm. So what I'm going to do, what should be the dissipation rate across this R1? So again, I have to use the formula for the power. So as we already solved one question in the previous video, so you just go back to the video and have the look. So better I can just work out one more time. So we have 3 rules. What are the rules? Power P, which is equal to the current multiplied by EMF. Power P, which is equal to the current square multiplied by the resistors. And then power P, which is equal to EMF square divided by resistor. So these are all the 3 rules we have. So here our question is related with the resistors and current. So I am going to pick this rule for this second part. So what is the rule? Power P, which is equal to I square multiplied by R1, because we are going to find what should be the dissipation rate across R1. And R1 value is already mentioned. What is the value of R1? The R1 takes the value of 4 ohm. So current, I have to take the value from the first part, which is 0.667 the whole square multiply with the resistors of R1 4 ohm. So let's see what is the answer for this part. So 0.667 square multiply with 4, I got the answer as 1.779. So I can round it the value to 1.78. And what is the unit for the power? Watt. Likewise, you have to find what should be the dissipation rate across R2. That is our third question, you can see. So you have to find the dissipation rate across R2. So we have to apply the same rule, but in place of R1, we have to use R2. So again, the third part, I'm going to use the same rule. Power P, which is equal to I square multiplied by R2. Here R2 takes the value of 8 ohm. So current same 0.667 the whole square multiply with 8. So let's see what is the answer. So when I just multiply with the current square, I got the answer as 3.559. So I can round it the value to 3.56 watt. So this is the answer for the third question. Clear? Okay. Now we have to go for the fourth question. In the fourth question, what they mention, what should be the energy transfer rate? If the word rate, if the word rate comes, means it's related to the power. So what should be the energy transfer rate across in battery 1? So in battery 1, what should be the energy transfer rate? Because here battery 1 is going to give the energy, right? So we are going to find what should be the power value for battery 1. So again, if you see this rule, I don't want to repeat the same thing again. So if you just see these rules, for the fourth question, this formula is perfectly matched. So here in this formula, I'm going to use power P, which is equal to current multiplied by the EMF of the first battery. And in the fifth question, I'm going to use the same rule. So I'm going to write this rule here for getting the answer for the fourth question. So what should be the energy transfer rate? So this is the D part, right? So what should be the energy transfer rate in battery 1? So energy transfer rate in battery 1, which is equal to P, which is equal to the current multiplied by the EMF of the first battery. The EMF of the first battery. So what is the current? As we already found the answer in the first part, the current takes the value of 0.667 multiplied by our EMF of the first battery. So what is the EMF of the first battery? Which is 12 volt, right? So multiplied by 12. So let's see what is the answer. 0.667 multiplied by 12. I got the answer here as 8 watt. So what is the answer here? 8 watt. The unit for the power is 8 watts. So this is the energy transfer rate across the EMF 1. Likewise, we have to find what should be the energy transfer rate in the second battery EMF. So that means our fifth question, power P, which is equal to I multiplied by the second battery EMF. And here the second battery EMF is given in the question as 4 volt. And the current we already found in the first part as 0.667 multiply with 4. So let's see what is the answer. So when I just multiply 0.667 with 4, I got the answer here as 2.668. So better I can round it the value to 2.67, and the unit for the power is watt. Clear? Okay. Now we have to go back to the sixth question and the seventh question, because the sixth question and the seventh question, you have to read the questions very carefully. So what is given in the question? Is energy being supplied or absorbed by battery 1, or is energy is being supplied or absorbed by battery 2? So what they ask, you have two batteries, EMF. Which battery is going to supply the energy and which battery is going to absorb the energy? So that answer you have to give. So generally, if you see this circuit diagram, our first battery EMF is stronger. So that means the current from the first battery we have just considered for this question, right? So that means here the energy is going to deliver from this first battery is supplier. So that means the first battery is going to give the energy. So that means it is a supplier. And the second battery is going to absorb. Why? Because you can see the arrow mark is opposite to this. So the first battery is going to give the energy and the second battery is going to absorb the energy. Clear? So generally we are just using the same principle. If your car stops, if your battery in the car, the battery in the car drains, what we will do, we will just take the booster wire and we will just connect the positive terminal of the battery with the positive terminal of the big car battery. Am I right? The weak battery of the car we just connected. So in that manner we are just giving the energy to the weak battery, right? The same principle here. So here the first battery is going to give the energy and the second battery is going to absorb the energy. That means the first battery is the supplier and the second battery is the absorber. Clear? So what is the answer for the seventh question and the eighth question? So F part and G part. So F part, EMF 1 is acting as a supplier. That means the E1 battery is going to discharge because it is providing the energy, right? Likewise, in the seventh question, your E2 battery is the absorber, so it is going to charging. Clear? So the concept, because the first battery is, if you see the value, this is 12-volt battery, this is 4-volt battery. So when you just see the circuit diagram, both the one will give the energy, one will absorb, the one will gain the energy. So this is the answer for the last two part. Clear? That's it. Thank you.